Yeah, hello everyone. Thank you very much. It's really a pleasure to be here and have the chance to talk about the topics that we do at the AIT. Resilience of cities is, of course, very important to increase our livability, even during times such as we experience right now with the ongoing COVID-19 pandemic. And what we have seen is in the past year, that the pandemic has really an effect on us on many levels. We have lockdown, we have home office and homeschooling, but it has also an effect on the mobility behavior. And what we can see is a decrease, of course, in travel and trips for work and shopping, but we see an increase also in ordering our daily needs online, and a decrease, on the other hand, again, in public transport usage that we can experience. So, but let's have a closer look. What does that really mean for our mobility system? If we look in our behavior, how has that changed? For which purposes do we need mobility? How have our daily routines changed? And is the leisure travel on hold, such as for tourism, as we can see here on this picture? One way to answer these questions is that we can use traffic flow models that we have also developed at the AIT. So one use case where we applied that we can see here. So we have basically the measured modal split, so public transport, walking, biking, and individual car use. And we have on the lower part of this picture our simulated modal split that we can see and that we can model. So this is all pre-pandemic. And if we look now during the pandemic, we collect data from Google and TomTom. They made this data publicly available, and we can use that also for our research. We see how the modal shift has changed. So we see a decrease, as we said before, in different usages of public transport. The interesting question is, how can we also investigate that with our model when we now look into the different activities? So, for instance, during the lockdown, there was the education trip purposes completely on zero. There was a strong decrease on shopping and so on. So there are two takeaways when we apply our simulation tool here. The first one is that if we look at the simulation model that is calibrated on the activities, we cannot really reflect the modal split. So there is a difference between what people did in the modal split and what the model predict, which gives us insight that we need to also look into how mobility behavior has changed for each individual activity. And the second takeaway is, with the data that we have available, we can also calibrate our models and use them ideally for predictions during the pandemic time, but also later on as we see a way out into a different mobility behavior. And these types of models are very helpful for us in many ways to test and assess different strategies in our mobility system. They are able to represent our mobility behavior on the different choice levels, such as the travel demand, how we plan our activities, but also on the mode choice, route choice, and then finally also on the evaluation of the evolution of the flows. And what we can see here in this picture is a multi-agent simulation model, a MATSIM model that we have developed for the city of Vienna, and that is calibrated on the data of Vienna, and is also publicly available under the link that you can see here in this picture. This is something we do at AIT. In our Urban Competence Hub, where we integrate the different domains of cities, so we can combine and integrate mobility, urban planning, energy, and climate to put that all together and help cities to become more sustainable and also more resilient, of course. And we have the different methods and tools to empower the different stakeholders to support the decision making and also give a pathway to more climate neutral cities and sustainable living spaces. So how are we doing this? One important tool that we have created is the City Intelligence Lab that Lena mentioned earlier. So this is a digital platform that integrates different digital tools for interaction, planning tools based on simulation, and also artificial intelligence methods that can enhance and accelerate the planning process. And it's also in collaboration very closely with the cities, with the industry, but also with the academic and research entities. So we can see here the different impressions on the technologies that we apply from the different visualizations towards augmented reality and virtual reality that can help us in the planning process. And I have brought one example from the City Intelligence Lab, our infrared project, which is basically the capability using machine learning framework to have planning and simulations run in real time, so very fast, to see the outcomes if you plan cities in a different way, how that affects the different KPIs that we are interested in the city. So basically, our approach here is that we start with the impact at the end. So this is in our main focus. And we have a performance-based spatial and transportation planning approach that accumulates all the different disciplines that we need, that we can see here, from landscaping to mobility to climate and energy and urban planning. And we can continuously assess the performance and measure it against the different KPIs that we can here see below. And the parametric design methods that we have developed help us to understand how we can transform our urban spaces and how to efficiently develop these different design scenarios, and then also look into them in terms of solar radiation, wind flow, and so on. Another aspect is, of course, that we can look on the impacts on accessibility on the different levels of the city. And this helps us to develop new concepts and understand how the 15-minute city or the superblock concept can help us to improve our cities also for resilience. How are we doing this? So we start with a layer of the built environment. We look at the demand, the public transport, the green area in the city, and then we can identify spots where we have to have a closer look. And at these spots, we can go more into the details, and we can better understand pre-pandemic, how was the use for public transport. During the pandemic and afterwards, there is a stronger need of green space. Is there an accessibility for this green space as well? So this helps us in the parametric model to look into these different scenarios and test them, also for traffic calming measures, and to evaluate the different designs on, let's say, a specific road, how we design that and evaluate towards different KPIs. Also, on the small scale, if you look at infrastructures, and this is a project that we did at Gare de Lyon with our partners from the MIT Sensible City Lab, we can better understand how people move in these infrastructures by measuring the behavior and using the simulations to extrapolate the behavior on the whole population, on the overall number of passengers in this metro station, and test different scenarios, how we can improve for transport, but also for retail purposes, and so on. This is, of course, also an impact when we look into the scenarios for COVID-19 and crisis where social distance is important. So we also looked into concepts how to improve the flows and separate them in metro stations. Here we can see a before without measures and a picture with measures to separate the transport flows, passenger flows. And we can see that the contact times in these stations have decreased significantly, and we can see that there is an improvement, while at the same time the walking times for the passengers and transfer between the modes of transport has not increased that much. So it is a help for operating these infrastructures. Similarly, we have implemented our simulations together with the partners from Schönbrunn Palace to support them in times where visitors need to be managed in a way that we can ensure that there is less contact, but also to give them an understanding for a way out of the pandemic when we start tourism and increase the efforts for tourism, how that can be managed in a very safe and efficient way. So that brings me to the last slide. Clearly we can see from what we have learned from our research and the developments that this new design, co-creation design and interaction methods can help us towards more resilient cities. It can also improve the design and also give a better understanding to all the different stakeholders, even in real time, to make decisions and see the impacts through the usage of artificial intelligence methods that we have developed. So with that, thank you very much, and I'm happy to address any questions.